Another example on verifying trig identities. Here's the problem we give you. The tangent of x plus the cotangent of x equals the secant of x times the cosecant of x. And we want to verify that this equation is true, as the left side does in fact equal the right side. So the technique we're going to use is we're going to rewrite one of the sides to all sines and cosines. So I'm going to pick the left-hand side. If you need to pause this video, please do so. Make sure you have your formula sheet out on your desk too when you're watching this video. So we're going to work with the left-hand side. We want to rewrite this to all sines and cosines. So right now we have the tangent of x and the cotangent of x. So both of these are being able to be rewritten with the quotient identity. So I'm going to rewrite that piece, and we're going to rewrite this piece also with the quotient identity. So maybe you want to take a minute to look at your formula sheet and look at the quotient identities for tangent of x and cotangent of x. So the tangent of x can be rewritten as the sine of x over the cosine of x, and then the cotangent of x, its quotient is cosine of x plus sine of x. Now the next thing we want to do after we've rewritten this to all sines and cosines is combine these two fractions together. If we look at the denominators right now, we have the cosine of x and the sine of x. They're not alike. We can't add them together as one. Why we want to add them together is because this is a multiplication of secant of x times the cosecant of x. So how do we get these two fractions to be alike? We want to find the common denominator. There's nothing in common with the cosine of x and the sine of x in the denominator, so that is what we call our least common denominator. So we need to find out what we're missing. So if we look at this first fraction in the purple here, we have the cosine of x, but we're missing this sine of x. So we're going to increase this first fraction by a sine of x and a sine of x. Now if we go to the second fraction has the sine of x, but it does not have the cosine of x. So we need to increase the second fraction by the cosine of x, cosine of x. Think about a fraction, cosine of x divided by cosine of x can be canceled out. So now are these two fractions alike? Do they have the same exact denominator? Do they have a sine of x and a cosine of x? Yes. So now we can combine them into one fraction and clean up the numerators. Those are our next two steps. So cosine of x times cosine of x is cosine squared of x. And sine of x times sine of x is sine squared of x. And then we combine those together, and we get one fraction. Now let's look at this numerator. This numerator right here is the Pythagorean identity. Sine squared of x plus cosine squared of x. Find that on your formula sheet. What does it equal? It equals 1. So we can replace this whole thing with 1. So now we have 1 over the cosine of x, sine of x. Because this is our Pythagorean identity. All right, we're almost there. Now let's split it up into two fractions. So we have 1 over the cosine of x. Last night's smart board connection here. We have 1 over the cosine of x. And then we have 1 over the sine of x. So they're two separate fractions. And you're going to notice that both of these are reciprocal identities. So on your formula sheet, check out your reciprocal identities. What is 1 over the cosine of x? What is 1 over the sine of x? Do you find those on your formula sheet? Well, they equal 1 over the cosine of x equals secant of x, And 1 over the sine of x equals cosecant of x. Have we now proven that this left side equals the right side? Let's head back up to our original problem. We wanted secant of x times cosecant of x, and we got it. So we've just verified this identity.